Okay, so these items here are kind of the same items here. So let's talk about this. Let's go through these one at a time. So account management is a human problem. Um, Now, the best way I can explain is I'm creating a computer program to manage people's financial or bank accounts, and this is a human issue. Now, without a computer of any sort, what I would have is I would have a folder, one folder for each client. Excuse me, one folder object for each client. All right, and within that folder, I would have all the data, okay, related to the client. Notice that this folder is encapsulated or protected from other folders. Many folders can exist at once. Each one has its own data that is separated from everyone else and basically invisible from everyone else. This folder has nothing to do with any other folder really, unless I say, unless I make a relationship between this folder and another folder. Anyways, so without a computer program, I would have a folder for a client. And what I would also have is I would have a deposit slip. And on that deposit slip, I would have the amount I want to deposit. Okay. Now, as a human being, as a human being processing this deposit slip, what I would do is I would look at this number, and if I see a negative sign here, someone wants us to deposit a negative amount, I would have said to myself, well, this is not a valid deposit slip. Don't make the deposit. So I would, as a human being, like I said, I would check it if it's positive or not. If it's positive, then go ahead and make the deposit. If it's negative, then don't do it. All right. So so what I just described to you is basically a human problem, okay, for which we're going to use a computer to solve that problem. Okay, so now now that we define that, account management is a human problem, and we're going to use computers to solve the human problem, now I'm going to explain to you as quickly and as simply as I can, simple example, that object-oriented programming, what it does in a nutshell is it models human problem solving, or at least tries to. It shouldn't be a big surprise because computers solve human problems, and OOP is meant to model the way we humans solve problems. Now, I'm going to use an example, a simple one, and like I said before, analogies suck for object-oriented programming. The reason is simply because, just to reiterate myself quickly, they're not going to work all the time. There's no analogy that I've read before that carried, that was able to explain everything in object-oriented programming. Eventually, you're going to have to make an exception, and that tends to confuse people who are new to this concept. So here's my example. So I want to make a hot dog. Now, in order to make a hot dog, I need to have a few objects. So I need a barbecue object. The barbecue object provides me the behaviors or the methods or the functionality I need to cook the hot dog. Simple as that. Now, without the barbecue, I can't cook the hot dog, and it's not going to work. But a barbecue is going to work on its own. Okay, I need the barbecue object to collaborate with the propane object. The propane object is going to provide a behavior or method or functionality of heat. Okay, and the collaboration between the barbecue object and the propane object I'm going to use to achieve my task or to solve a problem is to get my hot dog. Okay, so there's all kinds of other objects that I use, but you can see here that you can see here the collaboration of different objects to get to achieve to solve my problem. So I could go on forever with the examples on this, but if we look in our UML diagram, and this is a little less obvious, and maybe you'll understand why that I took that detour to show you that kind of a silly example of hot dogs and collaborating between a barbecue and a propane object, is what I'm about to do is I'm going to collaborate an object created from my validate class that provides me the isPositive functionality behavior method, and that's going to collaborate with an object created in my account class. Okay, and together between the two, I'm going to solve a problem. Okay, so uh, if that confuses you slightly, that's okay. You'll eventually before the end of the next video lesson, you'll see what I'm talking about. Okay, so the last item on this short list here is I wanted to model my computer program, or actually my in this case my computer program, or actually method behavior, like real. I want to model my method or behavior, which I'm about to create, like a real world problem solving. So like real logic in my in the algorithm I'm about to build. Now let me give you an example. Now, if I were looking at the deposits, if I were a banker before the age of computers, if I were to make this deposit for $1,000, I would look at this and I would say, is this number positive? If it's a positive number, then go ahead and make the deposit. And if it's not, then don't make the deposit. Now, what I just explained, what I just described to you, is how a human being would proceed after after looking at the deposit slip. Even though for most of you, you're saying, well, I wouldn't even think about that. Like that's something that just comes automatically. But for a computer, we have to tell it step by step what to do. So what I'm going to do is I'm going to take the logic that I just worked out, a very simple one, and I'm going to write it down, and we're going to turn it into a method or behavior so the computer can do this for us. Okay? So remember that those very few steps. So I'm going to go back to my program. I'm going to go back to my planning here. Okay, sorry, I'm going to go back to my UML. So the class is called validate, and the behavior is called is positive. So then I'm going to go to my planning and I'm going to start to plan this out here. So let's get started. Okay, so now the function name is called is positive. Okay, and it's going to need a number as a parameter. Okay, there we go. So what I'm going to do here is I'm going to start to introduce this kind of an idea, and this will kind of show up later. You'll maybe understand why I didn't do this before. Is I'm going to put a little plus there, and at the very end here, I'm going to go Boolean. Bracket here. Go. All right. And in a nutshell, this plus means that this method behavior is going to be public. The visibility of this method of behavior is public, meaning I can use it outside the class. And Boolean here, meaning that this method of behavior is gonna return a Boolean value. Okay. So actually, in my UML diagrams, I'm gonna add that little feature in as well. And if you haven't guessed it already, the reason why I didn't introduce this before is because for most of you that are doing this tutorial, you don't. You're beginners, and you're not going to know what it means. You're not going to know what your data types are. You're not going to know what visibility is, and you're not going to know what returning values are. Even right now, I'm talking about returning values. A good number of you are probably not going to know what I'm talking about, but that's okay. So in my UML diagram, I added a new feature because by now you should know what visibility means. So plus visibility means that it's available to be used outside of this class somewhere else. Okay, and Boolean, meaning that the value that is returned from this method is going to be of a type Boolean. It's either going to be true or false. We'll see that in a second. Okay, so here's where I'm going to basically repeat that very simple human algorithm, or the human logic, and I'm going to write it down in words. And then in the next lesson, I'm going to translate those words into something into steps that a computer can do. So what I want to do is I want to check if the number is positive. Okay, notice the name is positive. Okay, and if it is, then I'm going to go return true. If it isn't, then return false. Okay. So let me just test that. I'm looking at this number. Is it positive, true, or false? That's it.